Hey everybody, Harold here with another Polars data frame video. Today I want to talk to you about sum horizontal, and this is a great one for comparison to pandas. Um, because it's columnar and rust based, Polars can be 2 to 10 times faster than pandas performing these type of row-wise operations. Let me show you a speed test result I recently got. So I summed a million rows horizontally, 20 columns. Pandas did it in 0.19 milliseconds. Turtle. Polars did it in 0.03 milliseconds. So that's more than 6 times faster in that test alone. So lightning. I'll show you a really cool demo in a minute. First, I want to introduce you to the sum horizontal function itself. So I'm here in Colab. I'll publish this in my GitHub repo, add it to the description. I've imported in Polars as PL and Pandas as PD, and I've set my table columns, and from Rich I imported print. And I've got a little data set called golf, and it's 3 golfers and their scores on the first 9 holes. So we'll run that. Then we'll create a pandas data frame, and I'll show you what that looks like. So pddf equals pd.dataframe golf, and then we'll print pddf. Here we have a indexed data frame with Arnie, Jack, and Tiger, and their scores through the first 9 holes. And then we'll do the same thing in polars. So pldf equals pl.dataframe golf, and we'll rich print pldf. And that's a really nice looking table, I think. And it's the same information, just no index, and the player names and their scores through the first 9 holes. So row-wise sum across columns in pandas, you would say to create the new column at the end, pddf front 9 total equals pddf.filter any columns that have the word whole underscore in them, dot sum, and for row-wise you have to say axis equals 1. If you were doing columnar, it would be axis equals 0. So we'll run that cell, and there's our data frame with a new column with a front 9 total for each of the 3 golfers. Now, I want to do the same thing in polars. So here I'll say front 9 equals PLDF with columns, PL.sum underscore horizontal. Choose all columns, PL.col that are integer 64, PL.end64, and we're going to call that column .alias front 9 total, and then we'll print that. It's a 3x11 data frame. It's got our name, our scores, and our total for the front 9. Cool. With horizontal, you can do other functions besides sum. Just for example, here I did mean, max, and min. So I say PL mean horizontal, PL max horizontal, PL min horizontal, choose the integer columns. The mean will be average score, max would be the worst hole, and the min would be the best hole. So we'll run that and print the result. And Arnie's average score is 3.67. His worst hole was a 5, and his best hole was a 3. Jack's same 3.8, 6 and 3, Tiger 3.8, 4 and 3. But now for the real power demonstration, I'm going to show you a speed comparison I worked up. So for this, I need pandas as PD, polars as PL. We need NumPy and time to time it. I'm going to create a 1 million column, 20 row data frame of random integers using NumPy. So I say rows equals 1 million, columns equals 20, and our data equals np.random.randint from NumPy, number between 1 and 100 in rows for I in range columns. So random integers 1 to 100, a million rows for a range of 20 columns. I'll see PDF equals pd.dataframe data, and in Polars I'll say PLDF equals pl.dataframe data. So let's run it in pandas and see what happens. We have a start, it's time.perf counter, PDF row sum equals PDF sum axis 1, and then end time. And the pandas time would be end minus start. So we'll run that cell, and it did it in 0.162 milliseconds. Then we'll go to polars, the same thing with the time, but we'll use the polar sum horizontal, all rows, called row sum, and we will run that cell. Now that one is 0.07 to pandas 0.16, polars 0.07. So as you see, polars is at least twice as fast as pandas. If I run them a few more times, I got a 0.23 in pandas, 0.05. Now we're up to 4.5 times. We got 4 times there. Let's run it a few more times. Here, it's 6 times, and I've got to where it's been up to 10 times, but I won't keep running it. You guys get the idea. Turtle, pandas, lightning, polars. It's just so much faster on these row-wise operations. Why polars wins? When doing row-wise, so polars often significantly outperforms pandas. It's slower because pandas struggles with the row-wise operations. Axis operations often fall back to just looping, and row by row processing reduces the benefits you get from vectorization. It's less parallelized, limited multi-threading for row-wise ops. So you're running many ops in a single thread, and it takes a lot of memory overhead because data's processed row-wise, increasing cache misses, and intermediate object creation adds even more overhead. Now polars got a crab here because for us, for you crustaceans, why it's faster. Polars is built for performance from the ground up on our Rust engine. Core computations written in Rust. Near zero overhead. It's vectorized with horizontal kernels, so the row-wise ops are optimized internally. No Python loops at all. Automatically distributes across cores. It's multi-threaded by default, so we're efficiently using our modern hardware. In summary, feature execution into Python for pandas, Rust for polars, which is faster. Row-wise ops are slow for pandas, axis equals 1, fast for polars, sum horizontal. Pandas has limited parallelism. Polars has built-in multi-threading. Pandas has moderate memory efficiency. Polars has high. At scale, Pandas degrades quickly. Polars scales well to millions and millions of rows. So you want to take away from this, if you're doing a heavy row-wise analytics, feature engineering, or scoring systems, Polars is the better choice. Pandas is fine for small data sets, but Polars is built for speed at scale. So that's all I have on the sum horizontal. I hope you liked the speed comparison. I hope you liked this video. If you did, please like it, subscribe, and I will see you next time. Thanks, everybody.